Hello everyone. So we have been discussing all the things regarding media processing, communication, various protocols, and the various ways we can use them. You might have studied in the previous classes about SIV, about video compression, all those stuffs. So today's class is going to be a little bit practical approach, more into the application part, like whatever you have learned, how we can use it, how we can reuse it, or how industries are using it, or how we can do our research and innovate on designing some of the common problems of the current situation. By the way, I am Alok Nikhil. I am working with Adobe Systems as a consultant, and I would be taking your today's class, and it would be more about the applications part. So it's going to be a little bit interesting. So till now we have discussed about Adobe video attributes, communication mechanisms. The possible applications, whatever you have studied till now, is not very limited. It has a very wider scope. I mean, you can use it in a lot of places. I just tried to jot down some of the common places which is very easily accessible at the level of your scope. So that would be real-time multimedia applications, video teleconferencing, obviously, which what we are doing right now, internet telephony or VoIP, which we or you or somebody, at least whoever is using Gmail or Skype must have used at least once, wherein we do a audio chat or video chat. Internet audio video streaming, so this is what we see in everyday life. If you go to youtube.com, you see them. Internet multimedia, interactive video games, so these all are the multimedia, and games are the common things that you play the games online. So most of the games which is available on the cloud, they are actually based on the streaming technologies. Video storage. So video storage is like that. There are two kind of videos which you see on YouTube. One is what we call it streaming. You see that as soon as it keeps on downloading, you are able to view it. And in some situations you might have seen in past, you have internet, you downloaded a video on your YouTube, you disconnected your internet, you play the video YouTube player n number of times and you can see that. So that is what we call video storage, a caching technology. And the other case, like in today's situation, you might see this at every video. So every time you have to download and you have to view it. Video surveillance, database service and archives, emerging systems, which is where like a lot of world is working on these research, and broadcasting. That like if you during cricket, like you can see all those cricket everywhere on the internet, or you can see Aaj Tak or NDTV on your internet. So that is kind of broadcasting. So during today's class, we would learn some of the practical implementations, work out some of the possible use cases. We'll see what companies and industries are using it, and I'll just try to make sure that you get some interest. At least by the end of this lecture, you know what you have studied, how you can implement it. Analyze some of the aspects of the telemedicine, e-education, their aspects and applications, wherein like India and a lot of countries outside our Asia and North America, they are working on. And we'll know how we can use these technologies at various levels. We'll discuss one small case studies as well. So in the past class, we have studied about SIP technology, and like I'll give you a little brief overview, then we'll discuss an interesting case, like how we can use the SIP technology, how beneficial it is. So if you see this picture, so here we have 3 clouds. So let's start with basic things like SIP technology. You all know it's a session initiation protocol. So in simple language, SIP is nothing. It's just like a way to create a communication. Like I'm communicating with you, and my voice, my image, my video, it's all going through you, is not taken care by SIP. SIP makes sure that I have a connection with you. That's what the role of SIP is. And that's a very, that has got a very wider scope. So in this whole image, you see asterisk server, OpenSCR, that is SIP proxy registrar, OpenLDAP, Radius server. And so this is the part of network which I would call as a SIP. So OpenLDAP, LDAP is nothing like when you log into your Gmail, you enter your email ID. If you work in a company or even in the colleges, you might have got your unique ID, and whenever you log in, you put that unique ID, and that would be taken care by LDAP, which is Directory Authentication Server. So SIP works with LDAP. How it works, I'll tell you in a moment. So what happens, SIP basically makes a system wherein if I want to talk to any one of you, so I would not call you by your name. I'll make sure that I have a structure which has got your name with some domain name. For example, some person is XYZ, so when I want to talk to XYZ, I'll connect to xyz@dayalbag.com or xyz@iit.com. So this iit.com is, you can say, is an email ID, or can be your domain name, or is whatever you want to define it. So if it is in a local network, you can define it whatever you feel. If it is on an external network, you have to follow whatever the available domains. With SIP, I can connect to you guys in a local network, or in a network where I'm not using internet, or in a network where I'm using internet. So that communication would be voice over IP. Now, for example, if I want to call someone on the mobile phone, so I have to use the PSTN part, or I have to use a PBX server. So you might have seen, if you would have used Skype or Google Talk. So we do see an option wherein you can make calling to some numbers, like people who go outside India, or someone whose relative is outside India, or friends are outside India. When you call them, you rather call them through your Google Talk and dial in their number, you talk to them. So this is a kind of SIP architecture wherein you are using internet, you are talking to someone who is not on internet but on an analog line, on a phone line. So all this communication in the back end is what is taken care by SIP. So this is the soft phone. So I'll tell you later how this image is very much give you a very good idea of how you can design some small project if you want to do it at your hostel or at your college or something of that sort of very small domain. So most of these things have already been covered. I was just wanting to give you a quick overview how it works. So in this diagram, you see a radius server. So radius server is for accounting. Like I made a call to a US to my friend. I'm talking from my headphone and mic through my Gtalk, dialed the number. Now I have to pay some amount. So that accounting is taken care by radius server. SIP proxy registrar is for the registration, and SIP phone. SIP phone are the modern phones, like if you go to your conference room or if you go to industries. So we don't use the normal handset that we have at our house. That's a very normal analog phone. But in SIP phone, the phone is kind of designed, has got the codecs to talk to another SIP device. So in this room, in this teleconference center, so the camera, which is a SIP enabled camera, the Tandberg systems, they have got the SIP module. They are not simply a camera, that kind of digital camera. They can take your audio, video, they have the power to transmit it, they have a power to talk to some other SIP device. They have got all those modules inside. So this is a very, very common thing. You have already studied that. It follows the RFC 3261 designed by Internet Engineering Task Force. It is widely used to initiate and terminate voice over IP. So initiate and terminate, like I said, setting up a communication channel, not communicate, just set up the communication channel, initiate it, send a registration. I'll say hello, you'll say hello. So it means a kind of status 200, okay, connection set, SIP's work is done. It makes sure that connection is alive, keep alive session we call it. It is signaling protocol for establishing session in IP network, very much clear. It's a layer 7 protocol on the OSI. It listens on port 5060. So when we talk about SIP, so I've maintained the communication channel. I've set up that, hey, I'm able to hear you, you are able to hear me. Now what? How I have to send the data? So that is taken care by any streaming protocol, or here for that matter, I'm using RTP. So SIP initiate the session. SIP does not carry any voice, data, image, or anything, be it anything. SIP merely allows two endpoints like me and Dayalbag at this point. They can set up a connection. Now when I'm talking, so right now this mic is taking my audio, it is digitizing it, and then it is posting it to various routers and networks, and it's coming to you guys. And this thing is taken care by some protocol which is not SIP, which is my streaming protocol, or I'm considering it RTP for that matter. So in this diagram, if you see it, so this is SIP client caller and a SIP client destination, and this, my request will go to SIP1, then SIP2, then SIP3, and then it is reaching to Dayalbag. So once this connection is established, so after that when I'm talking, this talk would not, of course, go from always this SIP following by proxy 1, proxy 2, proxy 3 way. It will be a direct path. For example, like This is my one phone, this is my other phone, so I designed 3 proxy. So this path would be established first. Once it is done, so all my communication would happen this way. All the communication. So when I say this way, it means it's not this way, like A and B are talking always. It would be, they will identify which one is the lowest path. If they are able to get through this thing or get through this thing, or there might be many switches in between which are taking care of these SIP proxy servers. So it will try to find out the lowest path. So real-time transport protocol is a standard packet format for delivering audio and video. It is extensively used in communication entertainment system. Mostly it's, it was invented with the matter of having things delivered live, not the recorded. So most of the things where we have to deliver live is generally in the case of entertainment. For example, cricket matter for me is a priority, or football match is a priority. But there are many other applications, like setting up security cameras and monitoring something, traffic monitoring. So all these aspects. It is designed for end-to-end real-time transfer of stream data. RTP protocol provides facility for jitter compensation. So this is something that we have already studied earlier. So if you have any questions anytime, feel free to stop me and ask, okay? Streaming. So we have already talked, when we download something, so there are 2 ways. One is called caching, second is called streaming. So caching is a very normal model, a very old model which has been used always since many years. If you want to see something, it has to come to your computer, and then only you can watch it. On YouTube, I'm talking about YouTube. Or if it is any other, your internal portal or any MP3 song, you're trying to download it, or you want to hear it, it has to come to your system. Then only it gets cached, and then you can watch it. If it is not cached, you won't be able to hear it or watch it. And during the process of caching, if internet goes off, whatever amount has been cached, you can hear it, watch it, or whatever process you are doing. So there's a problem. So what problem is that once you download some video, for example, I set up a company which gives online video lectures to students, and it's very useful. So what is the problem? How can I make money? If I give you someone a login ID, they're logged in, they watched everything, whenever they watch, it gets downloaded on the system. They can easily drag the files which got downloaded on my cache. I can easily pull it up from my local settings. So I have that actual video file. So I designed that you have to log in every time you watch, but once you watch it, it is cached. It comes to your system, and now you are the owner. You can do whatever you want. So how would I make money? So this is one practical problem. So what we thought of, that instead of caching, or instead of letting the user to download everything on the system, we will limit it. We will limit it in the sense that we would not let the user download everything, because if there is a recording of 1 hour, you would not watch 1 hour right away. You will start from 1 minute, 2 minutes, like this way. So what I'll do, I will use the streaming technology. Streaming technology, what it does, it would allow you to download, but not the complete recording. Once you start watching, it will start downloading. It will download the small packets. These packets are encrypted, so that even if you try to decrypt those packets from your cache, you won't be able to do that. So every time you start watching, you logged into my portal, you put your credentials, you try to watching some video on, for example, data structures, and you started watching stack. So you clicked on play button. By the 1 minute or 30 seconds, that packet you are able to view, and by the time you move to 31 seconds, so the packet which was back in the 30 seconds would be gone. It would be purged automatically. So deleted, purge means deleted from your cache. So every time you watch it, you have to download it. You have to connect it to the internet. And this is how I would be making money. So streaming technology has been spread suddenly in last 3-4 years. It has been spread a lot. So this is one business case I gave you, one practical case which companies are using. Now if I talk about why streaming, like caching is always good, streaming is a costly affair, but there are situations wherein I cannot use caching at all. For example, like here, whatever I'm writing here on this board or on this pad, you would not, if it would be a caching model, so if my bandwidth between you and me is not too good, so it has to first download it, and then you are able to see it. But if it is a streaming mode, so if I write S, you would be able to see the S immediately. If I write T, so by the time, even in the streaming, caching happens, but the caching size of packet is very, very tiny, small and encrypted. So if I talk about whiteboard sharing, online whiteboard sharing, or any learning management system like Blackboard or SumTotal, they have whiteboard sharing mechanisms. So it would not never work on caching technology. We have to use streaming. So that was like, giving you a basic idea what streaming is, why it is useful. So in this slide, if you see, second, third, fourth, fifth point, if the user only watches 5 minutes for a 30-minute video, then you only pay for a delivery for 5 minutes, not the whole video. So this is again a business model, like 30-minute video, and I tell you, by the time you are connected to internet, so you would be connected to internet for that 5 minutes or whatever the model is. You have not to be worried about paying that 25 minutes of video which you have not watched. Use it, pay it kind of model. Biggest disadvantage, again, you wanted to view a recording or some YouTube video, you viewed it, your internet is gone, and now you try to click on play bar again, you won't be able to view it because that was streamed video. Streamed can be done for the live sessions or offline sessions. Like I have a repository, I can stream that data just to make sure that my data is not reused by someone, unauthorized people, kind of security concerns and all these aspects. Okay. So this is like how streaming works. Like I just gave you a basic idea. I just need a streaming server. The streaming server is what it does. It's just a software system, software app server. What it does, any video, audio, or whatever comes to it, it breaks it into chunks, encrypt it, and then push it. Push it as the request comes. It's not like a caching or simply you designed a PHP web page, you used Apache and you set up a video repository, and at the client end when you click on play button you see video coming, you pause it, you disconnect from internet, you play it, you keep that video keep on running. So that's a normal web server, but in streaming we use a streaming server which has capacity of doing what a web server or application server does plus streaming part. So there's another protocol. So we talked about RTP first. Now there's another protocol which is called RTMP, real-time messaging protocol. Again, this is a streaming protocol. So web server is server which does the streaming. Now how it does the streaming, which is decided by the protocol it uses. So like RTMP is one, RTP is one, RTSP is one. So there are a couple of protocols. So this RTMP protocol, real-time messaging protocol, was designed by Macromedia and then taken care by Adobe now. So what it does, it works on the top of TCP and 1935 port by default. So one good thing which I would like to tell you here, like you might have seen once you open a website, the website request goes HTTP : or FTP : So these are the protocols which are recognized by your browser. But if you watch some of those live sessions going on, if you go to their source, so you would see they have a protocol like RTP : or RTMP : So these would not be recognized by a browser. If you just catch this URL, put it on your browser, hit enter. So your browser will say, hey, what is this protocol? I don't know. I know only HTTP, HTTPS and FTP. So like this, what we have to do when we are using RTMP, so we just wrap it. This RTMP would be inside a HTTP protocol. So once it goes on the transport layer on the internet, so it will check the HTTP, and inside the HTTP the RTMP would be wrapped up. So this is how it works. So you might have seen HTTPS, like wherein we add certificates, secure sites like Facebook, HTTPS facebook.com and HTTP facebook.com. So they have both the versions. So like that, this RTMP can be secured as well. Once I say secured, whenever there is a S, means it needs a certificate which we have to purchase from outside. And another aspect is that RTMP-E, which is RTMP real-time messaging protocol encrypted, which talks about very secure, like DoD, Department of Defense, US military, they use RTMP-E and RTMP-T communication for streaming their systems because of the security mechanism. And the fourth part is RTMP-T tunneled. So this is quite interesting. They all are referring to S, E and T, the extensions. They refer to making a system more secure. But in tunneling, what happens? It's just like creating a tunnel, a bridge, like we have tunnels on roads. So it just create a tunnel, create a single path, and on that path only one communication can happen, and that is a tunneled connection, which obviously has some cost in terms of bandwidth. If I have a X amount of bandwidth, I'm using a tunneled connection. So some delta X would be used in creating that tunnel, and then rest amount is for the transmission. So one good thing about RTMP is it can support 64 concurrent streams. For example, if I'm using an RTMP protocol here, and I can basically, like DEI is one school connected now, we have 64 different streams reflected at the same time, and each stream has a different capacity, like 1,000 users or 5,000 users, depending upon the configuration has been set. How you can do that in lab? You can use any of the available servers like Flash Media Server, FMS, WOWZA, WZA, WOWZA Media Server, or Red 5 server. So these are basically web servers which you need to do. Design your application whatever you want to use, and when you have to use, instead of Apache or Tomcat or any other application or web server, use these web servers. So whatever process you are doing, do it. No extra has to be done. They'll do the streaming instead of caching. Okay, so I was talking about a small experiment. So for example, in your hostel, you want to set up a video chat kind of system. So like, I believe most of you might have been staying in hostel. If not, so just consider a situation wherein I am in a hostel. So let's say this cloud represents a hostel, and I want to talk to everyone. That either I go to their room, or I just call them, or I just ping them on internet on some chat system and go and talk, whatever way of communication. But instead, if I want to use a system wherein I can actually do a video calling, and I don't use internet, without using internet, I want to do a video calling. So when I'm saying I'm not using internet, means I'm not going to use the Google facility or Skype or Facebook or anything for that matter. What I have, that in a hostel all the rooms are connected in a LAN, like as it is in the IIT Delhi or most of the hostels. So they are connected through a LAN network, and I want to set up a video call. So this is a quick small experiment that you can do. What you need, a small computer or a server computer wherein we have SIP server configured. Then for every room, it's like room A, B, C, D, E. For every room I have to do a configuration, like for room number A, whoever is staying in room number A, I'll set up a, once you go into the SIP, in the registrations part, we have to identify like how you want to give the domain. So for example, I'll give a domain like a@hostel.com, b@hostel.com, c@hostel.com. And for A, I define where is A, what is the IP address of A. For B, I define what is the IP address of B. For C, I define what is their address. So that configuration is set up. Then on A's room, on the A's computer, I'll install a soft phone. So in the first figure, I told you that there is something called soft phone. So whatever mobile device or phone that we have in our home is a hardware phone, and soft phone is a software phone. I install the soft phone application on my computer or on my mobile device, and I use that soft phone. Like I'm the user A, I want to talk to anyone user B. I launch that soft phone application. I just dial the domain name of that user or the extension of that user, which I have in a directory, call them. And if they want to talk, have a video chat, they want to have an audio chat, we can do it. Just like a phone that we have, we are not using any internet, we are not using anything. What we are using a local network. I set up a SIP server, and I'm just doing all these aspects. Now, what if I want to talk to my home, who are, let's say, in Trivandrum? I want to talk to my family. I'm an IIT hostel. I've set up a PSTN SIP servers connection. I want to talk to someone at my home. How can I do that? I cannot do that because I need to make this SIP server, which is streaming all my audio video. It needs to talk to a PSTN line or BISDN line or the phone line for simple terms, and they have to communicate together. Like how I will do? I'll just this is my SIP server, this is my hostel. It has to talk to some PSTN line, and then they do exchange, and then they call my home phone. So for this thing, I need to have something called PRI card. This is very costly. Second thing, I need to have a dedicated line. to have this thing set up in India. Because when I'm calling from SIP, we have a capacity that we may hide our identity, which is not legal in India. So this is like how you can set up everything. Obviously, you don't try for PSTN, but yes, if you want to do some kind of experiment, use any SIP server available, Office SIP or 3CX or any other SIP server, Asterisk, anything. Download the soft phone, Xlite or any other whatever is available free, and just try to experiment, and you are able to set up a very nice video calling software in your local environment. We'll discuss this thing again in some of the telemedicine aspect later. So now let's talk about some of the application like e-education, which is also what we are doing is a kind of e-education. So the basic aspects of e-education is interaction, engagement, measure, feedback, and communication. Interaction in the sense like right now it's a kind of one-way communication. I didn't hear any questions. So interaction means participation from the listeners and the person who is delivering the course. Video call, how can we do how we interact? Video call, audio call, voice talk, notes, or whiteboard. Whiteboard means either I write on this whiteboard or you can see it,